Hello and welcome back. Let's have a look at this question. Consider the family of functions with rules of the form f of x equals a open bracket 4 minus x squared in brackets squared, where a is a non-zero real number. Wow, yeah, okay, sure. 7a, find f dash of x in terms of x and a. So let's first of all write down what f of x is. F of x equals a open bracket 4 minus x squared close bracket squared. A is a non-zero real number. It just means it's a constant. We don't know what A is, but we could treat it like it's 5 or 10 or 15 or 1. It doesn't matter. It's just a constant in this case. Now it says find f dash of x. Now f dash of x is the same as saying dy dx, the derivative of the function with respect to x. Or because it was originally given in f of x form, you could do this. Oh, I wouldn't. But that's up to you and what you're used to. So what I'm going to do is I'm just going to say this thing equals y. And then from there, I'm going to use my dy dx notation just because it's a little bit nicer and much more accurate. It's much more useful in helping us out. So let's have a look. If we say that y is equal to a u squared, there's a multiply in between those two, we can find out what dy du is. So this would just be 2au. Now u, what the heck is u? What is it? Well, it's just 4 minus x squared. Our y is a 4 minus x squared squared. So I just made that thing in the brackets a u. This is the chain rule in action right now, where we have a function within a function. We have 4 minus x squared inside of another function, in this case, a squared. So let's work out the derivative of u with respect to x now. So du dx, that's just negative 2x. That 4 disappears because it's a constant. Now, our original goal was f dash of x, which is dy dx. So dy dx is equal to dy du times du dx. Great, let's sub those in. We know what dy du is. It is 2au. And we know what du dx is. It's negative 2x. Now we can gather up some like terms. We can remember our u is actually 4 minus x squared, so we can rewrite that. So this will be negative 4 ax, and then the u, 4 minus x squared. There we go. And that would be f dash of x, or dy dx, in terms of x and a. We've got x's, we've got a's. So 7a is really just asking you to derive this. That's it. Now for part B. It says find in terms of a f dash of 1. So f dash of 1, that's just dy dx at x equals 1. So we know what dy dx is. It is our negative 4ax open bracket 4 minus x squared. Let's write that down first of all. Negative 4ax open bracket 4 minus x squared. So now we sub in x equals 1. That's it. Okay. This should be not that bad. Negative 4a 1. Whenever I sub in a value, I always like to use brackets. It helps me keep track of any negative signs or anything interesting going on, especially if it's not just 1. It could be another function that I'm subbing in. So I like to always use brackets. So let's expand and simplify this. This will be negative 4a. Inside here, 4 minus 1 squared. 1 squared is 1. 4 minus 1, that's 3. This is just going to be negative 12a. And that is f dash of 1. And that's b part 1. Now for B, part 2. The x-coordinates of the stationary points on the curve y equals f of x. The x-coordinates of the stationary points. So we're working with stationary points. If this term is new to you, don't worry. It relates to derivatives really nicely. The stationary point just means that the derivative is equal to 0. It means the gradient is 0. So we've got y dx. We know that equation. We're just subbing in 0 for y dx and solving for x. That's not too bad at all. Okay, let's do that. 0 equals negative 4ax, open bracket, 4 minus x squared. Oh, this is actually something that's really nice. We've got a function of x multiplied by another function of x. That means we can apply our null factor law, or maybe you call it the null factor theorem. It doesn't really matter. So that just means each function of x, one of them must equal 0. One of them. Otherwise, there's no other way you can make a 0 here. So that would mean we've got negative 4ax equals 0. That means x has to equal 0. Or we've got 4 minus x squared equals 0, which means 4 equals x squared. And that would mean that the square root of 4 is equal to x. But be careful. When you introduce a square root, there are always two possible answers, the positive and negative. So that means we've got positive and negative 2 equals x. So the x-coordinates of the stationary points. The stationary points, when you see that, it just means the derivative is 0. So we sub that in, and then we solved for x. That's it. We're done. Well, we could list this a little bit nicer. We could say that x is equal to negative 2, 0, or 2. Those are the x values, the x coordinates of the stationary points. Now for B, part 3. The equation of the tangent to the curve y equals f of x. Oh, I've already been working with y, that's all right. At x equals 1. Okay, so the tangent to the curve. What's a tangent? A tangent, fantastic writing, that says very clearly tangent. It's a straight line. Usually it's written in the form y equals mx plus c. And a tangent is a straight line that touches the curve once at x equals 1. So what that means is they share the same gradient. Gradient, that's the same as the derivative. So at x equals 1, what is the derivative? Well, luckily, we've already done that. It's right here. This is the gradient of the function y equals f of x at x equals 1. We've subbed in 1 already. We know our m value. So let's write that a little bit clearer. M is equal to dy dx. It's just our gradient. At a specific point at 1, we know that the m value is negative 12a. Well, let's write that down. Let's sub it in. Y equals negative 12a times x plus c. Now, to work out a tangent, you need your m value and your c value. We don't have c. Oh no, but can we get an x and a y value? Yes, we can. We have x is 1. We know that. We know x equals 1. But what is y? Let's look back at our original function all the way back over here. Here, we've got y. We can solve for y. Do we know x? Yes, they gave us x. It's 1. So let's write this down. Y is equal to a open bracket 4 minus x squared close bracket squared. So we sub in x equals 1. Let's see what we get. Y equals a open bracket 4 minus 1 in brackets squared close bracket squared. Y will equal a 4 minus, well, hold on, 1 squared is 1, 4 minus 1 is 3. 3 squared is 9. Oh, I love that they put a 9 and an a together. They definitely look different and unique. So we have 9a. That's our y value. So we've got a coordinate, an x value and a y value. So that means we've got 1, 9a. Now don't be worried. Y, of course it's going to have an a in it because our original function has that constant. We don't know what it is. It doesn't matter. It's just a constant. It could be 1, it could be 2, whatever. Now that we've got an x and a y value, we can sub that into our tangent formula to find our c value. So let's do that now. We've got 9a. I'm going to write a little tick, a running a there, just to make it a little bit separate from my 9. That will equal negative 12a times 1 plus c. Let's get the c by itself. Let's add 12a to both sides. That'll give me 21a equals c. Fantastic. So I've got an m value, which is negative 12a, and our c value, 21a. So the equation to the tangent is just going to be y equals negative 12ax plus 21a. And that will be the equation of the tangent. You might be thinking, you've worked out x and y, why don't you put them in? Well, if we don't have x or y, we won't have an equation of a tangent. You'll just have something that says 9a equals 9a, and that is not an equation of a tangent. We need the y and we need the x written as y and x for it to be an equation of a tangent. All right, thanks for joining me, and I'll see you next time.